This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on MaxMin problems as well as some integrals. We start with the function g of x is 5 minus the cube root of x minus 4 squared, and our goal is to find the absolute minimum and absolute maximum for this function on the interval from 3 to 12. So let's rewrite the function as 5 minus x minus 4 to the 2/3. 2 is the numerator of the exponent, 3, the index of the root, is the denominator. And we want to go ahead and find all critical values. Critical values will be points where the first derivative is 0 or where the first derivative does not exist. So we need to find the derivative of g. So we take the derivative of 5 minus the derivative of x minus 4 to the 2/3. The derivative of 5 is 0. The derivative of x minus 4 to the 2/3 would be 2/3. X minus 4 to the 2/3 minus 1 times the derivative of the inside times 1. So 0 minus 2/3 x minus 4 to the negative 1/3. 2/3 minus 1 is negative 1/3 times 1. And rewriting that, negative 2/3 x minus 4 to the negative 1/3 is negative 2/3 times x minus 4 to the 1/3. And we're looking for critical points. Critical points, again, where the first derivative is 0 or where the first derivative does not exist. This is never 0. This is a fraction. The denominator is never 0. But it doesn't exist if the denominator is 0. So you can recognize if we plug in a 4 for x, the derivative g prime of 4 will not exist. 4 will be a critical value. So negative 2/3 times the cube root of x minus 4. Finding the critical values, recognizing g prime of 4 is negative 2/0, that is undefined. G prime of 4 does not exist, so 4 is indeed a critical value. What is also important, though, is 4 is between 3 and 12. We're interested in this interval. We are going to check the endpoints as well as any critical points in between them. 4 is a critical point between them. So we're going to check 3, we're going to check 4, we're going to check 12. Plugging in 3. 3 minus 4 is negative 1. Negative 1 squared is positive 1. Cube root of 1 is 1. 5 minus 1 is 4. So plugging in an x value of 3, the y value is 4. Our critical value is 4. Let's do that one next. 4 minus 4 is 0. Squared is 0. Cube root of 0 is 0. We get 5. And lastly, we're going to plug in our other endpoint, which is 12. 12 minus 4 is 8. 8 squared is 64. Cube root of 64 is 4. 4 times 4 times 4 is 64, so we get 5 minus 4 is 1. The highest of the high is the absolute max. The lowest of the low is the absolute min. Absolute max here of 5 occurs at x equals 4. Absolute min of 1 occurs at x equals 12. Again, 5 is the highest of the high. 1 is the lowest of the low. Absolute max of 5 when x is 4. Absolute min of 1 when x is 12. Next question. A manufacturer sells a product for $1,000. At that price point, the demand is 10,000 units per week. For every $5 decrease in price, research shows that the demand will increase 1,000 units. So we need to figure out some way to convert this into a revenue function. We're going to define x as the number of price decreases. So if there's one price decrease, it'll go from $100 to $95. If there's two price decreases, it'll go from $100 to $90. So our price is 100 minus 5 times the number of price decreases. Now, as the price decreases, the demand goes up. We are starting with 10,000 units. If we decrease it by $5, it'll go up 1,000. So our demand is starting with 10,000 units plus 1,000 for each price decrease. 10,000 units plus 1,000x. Now revenue is the number of items we sell times the price per item. So the number of items we sell will be our demand, and our price per item is the price. Putting those together, 10,000 plus 1,000x times 100 minus 5x will be our revenue function. Multiplying this out, 10,000 times 100 is 1,000,000. 10,000 times negative 5x, negative 50,000x. 1000x times 100, positive 100,000x, minus 5x times 1000x minus 5000x squared. And you'll notice we have 100,000x minus 50,000x, like terms there. So we get our revenue function is 1 million plus 50,000x minus 5,000x squared. And our goal is to maximize revenue. So we will take the first derivative, find our critical values, and determine where the maximum value will be. So there's our revenue function, first derivative, 50,000 minus 10,000x. Critical values will be where the first derivative is 0 or where the first derivative does not exist. So we get 10,000x is 50,000. Dividing by 10,000, we get x is 5. Now notice the second derivative is negative 10,000. The second derivative is always negative. That means it's concave down. If we have a concave down situation, our critical value will be the absolute maximum. So we'll have maximum revenue when x is 5. Remember, that meant 5 decreases. Each decrease was $5. So we're going to knock knock $25 off the price. So it'll go from 100 to 75. So our price function was 100 minus 5x. We said we had maximum revenue when x is 5. 100 minus 5 times 5. 100 minus 25 is 75. Our demand function was 10,000 plus 1,000 times 5. So our demand grows to 15,000 at $75 per unit. So our maximum revenue will be the total number we sold times the price per unit. 15,000 times 75. Maximum revenue of $1,125,000 if we set a price point of $75 to get a demand of 15,000. Our next question is, a company manufactures and sells X digital cameras per week. The weekly price demand function is P equals 400 minus 0.4x, and the weekly cost function, C of X, is 2,000 plus 160x. We want to know how many items should be manufactured and sold to maximize revenue. So we have to define revenue. X is our demand and P is our price. Revenue is the demand, number of items, times price per item. So the revenue function is X times P. So what we get here is we get X times 400 minus 0.4x is our revenue function. Distributing that, we get revenue function is 400x minus 0.4x squared. To find critical values, take the first derivative and set it equal to 0. So 400 minus 0.8x, set it equal to 0. 0.8x is 400, dividing by 0.8x is 500. Now, is that a maximum or is that a minimum? How do we know? Well, we could take a second derivative again. Second derivative of this is what? Is negative 0.8, which is concave down, which means we will have a maximum revenue when the x value is 500. So let's continue with that then. There is our revenue function. We said it would be maximized because it's concave down at the critical value of 500. So the revenue of 500 is 400 times x of 500 minus 0.4 times 500 squared, and we have 100,000. So revenue is maximized when 500 items are sold. And the maximum revenue is $100,000. Okay, now we're going to add the cost function. So we have the cost function here of 2,000 plus 160x to go with our revenue function we did on the earlier portion. And we want to know how many items should be manufactured and sold to maximize profit. Profit is revenue minus cost. Revenue, 400x minus 0.4x squared minus cost, 2,000 plus 160x. Distribute the minus sign. So the profit is 400x minus 0.4x squared minus 2,000 minus 160x. 400x minus 160x would be 240x. So rewriting this as negative 0.4x squared plus 240x minus 2,000. We want to maximize profit, find critical values, take the first derivative. P prime will be negative 0.8x plus 240. Take the first derivative and set it equal to 0 or find out where it doesn't exist. 0 is negative 0.8x plus 240. 0.8x is 240. Dividing by 0.8, we get x is 300. Is that a minimum or a maximum? Same strategy as before. Let's look at the second derivative. P double prime is negative 8 again. That is concave down. If we have a concave down situation, there will be a maximum at our critical point. So max profit at x is 300. So there's our profit function. We know we're going to have a maximum profit at x equals 300. Let's plug 300 in. So P of 300, negative 0.4 times 300 squared plus 240 times 300 minus 2,000. Maximum profit of 34,000 when x is 300 units. All right, let's take a look at our next question. We have this function, f of x is x cubed plus 3x squared minus 9x minus 7. We want to find the absolute min and absolute max for this function on the interval from negative 6 to 2. We need critical values. Take the first derivative, set it equal to 0. First derivative, 3x squared plus 6x minus 9, set it equal to 0, or find out where it doesn't exist. We have a 3 in each of these terms. Let's factor out that 3. 0 is 3 times x squared plus 2x minus 3. Factor this, x plus 3 times x minus 1 equals 0. So we're going to get x plus 3 is 0 or x minus 1 is 0. So x is negative 3 or x is 1. Those are my only critical values. And notice they are both between negative 6 and 2. So you've got to check the endpoints, check negative 6 and 2. Check the critical points in between, check negative 3 and 1. Highest of the high is the max. Lowest of the low is the min. So again, we're going to check them both because they're in the interval. Let's go through that process. Plugging negative 6 into this function using the calculator is certainly a good idea. I get negative 61. Plugging negative 3 into the function, I get 20. Plugging 1 into the function, I get negative 12. Plugging 2 into the function, I get negative 5. Now, the highest of the high is the absolute max. Looks like the absolute max is 20, and that occurs at negative 3. The lowest of the low is negative 61, and that occurs at negative 6. So you'll notice I've highlighted those 2 points, and then we'll say f achieves an absolute min of negative 61 at x equals negative 6. F achieves an absolute max of 20 at x equals negative 3. Our next question is the integral of 5x squared plus 3 root x plus 9 over x plus 4e to the x. The integral of the sum is the sum of the integrals, integral of the first piece plus integral of the second piece plus integral of the third piece plus integral of the fourth piece. We can pull out all of the constants. 5 times the integral of x squared plus 3 times the integral of root x plus 9 times the integral of 1 over x plus 4 times the integral of e to the x. We want to use the power rule, so I want to rewrite square root of x as x to the 1/2 power. So once we're here, we're able to do this, keeping in mind our power rule as well as these 2 special cases. So our power rule is the integral of x to the n dx is x to the n plus 1 over n plus 1 plus c. Integral of x squared would be x to the 3rd over 3. Integral of x to the 1/2, 1/2 plus 1 is 3/2, x to the 3/2 over 3/2. Now the derivative of the natural log of x is 1 over x, so the integral of 1 over x is natural log of x. We just add absolute value because that's going to give us a larger domain for the function. And the derivative of e to the x is e to the x, so the integral of e to the x is e to the x. So again, 5x cubed over 3, 3x to the 3/2 over 3/2, 9 natural log absolute value of x, plus 4 e to the x plus c. We have a little bit of work to do here. 5 divided by 3 is just 5/3. That's not a problem. 3 divided by 3/2. We've got to do that. Invert and multiply. 3 divided by 3/2. 3 times 2/3. We just get 2. So this reduces to 2. So our final answer will be 5x to the 3rd over 3 plus 2x to the 3/2 plus 9 natural log of absolute x plus 4 e to the x plus c. Our next example is the integral of 3x squared plus 5 over 2 times the cube root of x. We have a single denominator here. We can break this up into the integral of this over this plus integral of this over this. And then we have to recognize that the cube root of x is x to the 1/3 power. Pulling out constants first, 3 over 2 is 3/2, 5 over 2 is 5/2. And again, x to the cube root of x is x to the 1/3 power. And when we have the same bases, we subtract the exponents. 2 minus 1/3, 6/3 minus 1/3, 5/3. So this first piece is 3/2 integral of 2 minus 1/3. 1 over x to the 1/3, of course, is x to the negative 1/3. So we get 3/2 integral of x to the 5/3, 2 minus 1/3 is 5/3, plus 5/2 integral of x to the negative 1/3 dx. And let's remember that the integral of x to the n dx is x to the n plus 1 over n plus 1. So the integral of x to the 5/3 would be x to the 7/3 over 7/3. Integral of x to the negative 1/3, let's see, adding 1 to that, x to the 2/3 over 2/3. Now here I have 3/2 divided by 7/3. Here I have 5/2 divided by 2/3. So 3/2 divided by 7/3 is 3/2 times 3/7, 9/14. So this becomes 9/14. Here 5/2 divided by 2/3 is 5/2 times 3/2 is 15/4. So these two fractions give me 9/4, and these two give me 15/4. Excuse me, 9/14 and 15/4. And that is our final answer to that problem. Next up, we have integral of 5x over the square root of 7x squared plus 11. We're going to do this with the u substitution. U will equal 7x squared plus 11. So the derivative of u with respect to x is what we're going for. So taking the derivative with respect to x of both sides, the derivative of u with respect to x is 14x. My goal is to solve for dx. So du is 14x dx. Dividing by 14x, du divided by 14x equals dx. So we'll go ahead and do this, make our substitution. All of the x's have to go away. 5x is 5x. This will be square root of u, and dx will be du divided by 14x. You'll notice the x's cancel. That's good news. The 5/14 is a constant, can come out in front. So we have 5/14 integral of 1 over root u du. Root u is u to the 1/2 power. 1 over u to the 1/2 power is u to the negative 1/2. And now we have to use our power rule again. X to the n plus 1 over n plus 1. Negative 1/2 plus 1 is 1/2. So 5/14 u to the 1/2 over 1/2. Which we finally got to. Using our power rule again, integral of x to the n dx, x to the n plus 1 over n plus 1, negative 1/2 plus 1/2, u to the 1/2 over 1, negative 1/2 plus 1 over 1/2. And now we have to divide these fractions. 5/14 divided by 1/2 is 5/14 times 2, so I got to fix that. So again, 5/14 divided by 1/2 is 5/14 times 2. 2 over 14 is 7, that's 5/7. So this divided by this is 5/7 u to the 1/2 plus c. But what is u? U is 7x squared plus 11, so it's 5 times square root of u over 7, 5 times square root of 7x squared plus 11 over 7. And that is fixed. So our final answer is 5 times the square root of 7x squared plus 11 all over 7. Our next question is the integral of 3x over x minus 4. This will also be done with the u substitution. How are we going to do that? We're going to let u equal x minus 4. Take the derivative with respect to x at both sides. The derivative with respect to x of u is du dx. The derivative with respect to x of x minus 4 is 1. So du equals dx, but that's not enough. I also need to solve for this x. And you'll recognize u is x minus 4. So if u is x minus 4, u plus 4 would have to be x. And now I've substituted out all of the x's. So there'll be 3x will be 3 times u plus 4 over u, and dx is du. Distribute the 3. So integral of 3u plus 12 over u du. Now break this up into two integrals. Integral of 3u over u du plus integral of 12 over u du. 3u over u is just 3, integral of 3 plus integral of 12 over u du. Integral of 3 with respect to u is just 3u, and this will be 12 times the natural log of absolute value of u, pulling the 12 out front. So indeed, 3u plus 12 times the log of the absolute value of u plus c. U is x minus 4. Replace that u with x minus 4 and that u with x minus 4. Distributing here, we could take that as 3x minus 12 plus 12 times the natural log of x minus 4 plus c. But the reality is negative 12 is just a constant. So we can think of this constant being absorbed into this constant. Negative 12 plus c is still just an arbitrary constant. So this answer isn't wrong, but this is a little better because we have we removed the unnecessary negative 12, the unnecessary constant, and just thought about it in one sense as the plus c at the end. And that will conclude this lesson.